Microwave background radiation, a trace of the universe's origins. Have you ever wondered what the universe looked like billions of years ago, right after the Big Bang? Maybe you imagine a vast explosion, dazzling flashes of light, and stars being born from chaos. That's a good start. But what if I told you that the answer to this question doesn't lie in the lights of stars, but in the quiet, almost invisible background? That's right. Hidden in what we call the cosmic microwave background, CMB, we find the fingerprint of the past, which tells us how our universe came to be. Let's embark on this incredible journey through time and space. What is the cosmic microwave background? To grasp this concept, imagine the universe as a gigantic balloon that began expanding rapidly after the Big Bang. But this wasn't an explosion like the ones we know on Earth. It was more like the continuous stretching of space in all directions, from the smallest particles to the largest galaxies. Even though today's universe is full of galaxies, stars and planets, in its early moments, it was incredibly hot, dense and empty. But this young universe, as hot as the surface of the sun, was glowing. This energy filled every inch of space. Over time, as the universe expanded, this radiation began to cool down, and its wavelength stretched. Finally, about 380,000 years after the Big Bang, this light cooled enough for atoms to form, and the radiation dispersed throughout the universe, leaving behind what we now call the cosmic microwave background. Today, this radiation is no longer hot. In fact, its temperature is only 2.725 Kelvin, just above 270 degrees. This makes it invisible to our eyes, but with special telescopes, we can detect it. How did we discover this cosmic soup? The story of how we discovered the CMB isn't just a fascinating part of astronomy, it's also a bit of a happy accident. In 1965, two scientists, Arno Penzias and Robert Wilson, working for Bell Labs, were trying to eliminate an annoying noise in their antennas. At first, they thought pigeons nesting in the antenna were to blame, so they cleaned out the bird droppings, but the noise persisted. No matter where they pointed the antenna, they kept hearing the same hiss. It wasn't until they consulted with scientists at Princeton University that they realized they had detected the afterglow of the Big Bang. This discovery earned them the Nobel Prize, the universe as a fingerprint. The cosmic microwave background isn't uniform. At first glance, it may seem completely smooth, but upon closer inspection, we can detect tiny fluctuations, differences in temperature and density. Imagine this as a map of warm and cold spots, like a weather forecast on a cosmic scale. These fluctuations are the key to understanding how galaxies, clusters of galaxies, and the entire structure of the universe formed over time. And here's a fun fact. Studying these slight temperature differences allowed scientists to accurately determine the age of the universe. We now know it's approximately 13.8 billion years old. Furthermore, thanks to the CMB, we've learned about dark matter and dark energy, mysterious components of the universe that still elude our full understanding. The universe in a cup, or cosmic coffee. Picture the universe as a giant cup of coffee. At the beginning, it was a boiling hot beverage, and the energy it emitted was so intense that no one could get close. Over time, the coffee began to cool, becoming pleasantly warm, just like our universe today. The cosmic microwave background is that delicate steam rising from the cup, a remnant of that intense hot period. While the cup may have cooled, this steam tells us a lot about what the universe was like when it was still hot. Recent discoveries and mysteries. Since Penzias and Wilson's discovery, astronomers around the world have worked to create increasingly detailed maps of this cosmic fingerprint. One of the most important projects in recent years is the Planck satellite, launched by the European Space Agency. Its mission was to measure fluctuations in the CMB and provide the most accurate map of the CMB ever created. Thanks to Planck, scientists were able to confirm the Big Bang Theory model of the universe with precision. However, not everything is so straightforward. Despite the detailed data Planck provided, some of it was surprising. For instance, certain fluctuations in the CMB appear larger than the theory predicted. Does this mean there's something we still don't know about the nature of dark matter? Could there be other unknown forces that influence the development of the universe? What's next? The cosmic microwave background is just the first step in uncovering the history of our universe. Every new telescope, every next study brings us more information, but also more questions. In recent years, astronomers have become increasingly interested in studying the early phases of galaxy formation and the mysterious dark matter and energy that make up about 95% of the universe's mass but remain invisible and hard to understand. It turns out the universe is far more complex than we could have ever imagined. However, by studying the CMB, we're learning how to piece together this puzzle. Who knows? In a few decades, we might have answers to questions that seem unreachable today. Conclusion: the cosmic microwave background is nothing less than the echo of the cosmic dawn, the moment when everything we know came into existence. It's an incredible relic of the past, a fingerprint left by the Big Bang that we can study to better understand where we come from. While it seems quiet and invisible, it hides secrets that can tell us more about the future of the universe than we can now imagine. The universe is a vast, complex structure, and each new study brings us to exciting discoveries. So, the next time you hear static on the radio or see grainy images on your TV screen, it may not be just random noise. It could be the echo of the Big Bang still resonating in our modern world. The cosmos never ceases to amaze. Are you ready for more?